All right, welcome everybody. Thank you all for joining in such big numbers. The numbers are still going up a little bit, so I'm going to do a short introduction so we can wait for everybody to call in. My name is Tom Mullendijks. I'm the founder of SteelTrace, and thank you all for coming to this webinar. We will start today with a presentation about blockchain by our COO, Yannick Dols. And afterwards, we will dive into the platform and show you how we apply blockchain in the supply chain of steel. So, Yannick, if you want to give it a go.
Yes. So, blockchain. We have heard the last years a lot about it. It was kind of a buzzword. And but what is the technology? So we will deep dive into basically short an introduction about the technology itself, and then look to the applications. So let me get the presentation. There we go. So yeah, the two of us, Tom already made the introduction. Many years ago, this picture was taken in January 2014. Blockchain was already for a long time there, since 2009, 2010, but it was still in the early phase. As you can see there, it was not a lot of people were there, and they were basically all nerds, everybody that liked to program, because it was not, let's say, accessible for everybody, because you still needed to type stuff in the command shell. So it was not something for everybody. It developed during the years much more and much more. And if you look to, for instance, the internet was, if we look 10 years back, we can see the internet really changed our life. If we look now, our smartphone is almost attached to our body, and we use it daily, the internet, much more, and it's much bigger applications, and it makes our life much more easier. And if you also look to the past about how the infrastructure was, about how we exchange data, is that basically in all the innovations, the complete infrastructure got replaced. So we had the printing press, the radio, the television, the internet. And now basically we have on top of the internet an extension, and that's the blockchain. And the internet, we can compare it, if we compare it to the human body, it's basically the internet connects us. It's like the blood vessels in the nerve system in our body that connects our body. And now on top of that, we get a collective brain, a collective logic. So yeah, but what is this technology now? Let's learn like the cool kids and speak blockchain. First of all, we will hear a lot about transactions. And these transactions that we talk about are not only monetary transactions, like we may be used to when we think about transactions, but these transactions are all, let's say, data-driven. So transaction could also be that I send you a message or something else. Because within the blockchain, we are basically bundling transactions records with data about something that happened and putting that in context. So blockchain is basically a business transaction controller. So then we have the ledger, and we all know the ledger probably from accounting, and it's very important, but we always use this basically somewhere stored centrally on your own computer, or maybe in the cloud when you use accounting software. And basically there is one source where it is stored. And everybody that has access to that source can also change, edit, and add records, for instance, to that ledger. When we look to the blockchain, it's basically a mega Excel sheet that we share throughout the whole world. But there are some simple rules around that. And that is that you can only add transactions. So we cannot, let's say, edit or remove a transaction. everything is open and transparent. So if we like Bitcoin is the most known example, and also the first example, basically all the transactions are open and transparent because that ledger is accessible. And basically these are anonymous accounts. They are not completely anonymous because the bank, let's say the bank account number, when you know that to a person, it's not anonymous anymore, but we don't know who, what bank account owns. So all transactions are transparent. They also have a time restraint. So basically all the transactions get a timestamp with them. And in this way, we get a chronologically ledger with all the transactions done. Yeah, maybe we all know from back in the days, Napster, for instance, or Kazaa, or we used BitTorrent. Basically, these were the first, let's say, applications of decentralization. While we are more used to normally have a centralized command and control structure, with blockchain, we use a decentralized structure, and this is peer-to-peer. So we do it together. So basically, we share everything also together. And the ledger that we then share underneath each other is managed by nodes. And the nodes are basically, everybody can participate, for instance, as a node. For instance, a blockchain, Bitcoin, for instance, has like more than 9,000 nodes running. And what the nodes basically do is basically they keep a copy of the ledger, of the complete ledger. And in this way, they communicate with each other to make sure that every copy is the same. With nodes, you also have like different types of nodes. For instance, you can have a validator, a node, which basically can execute, verify transactions, while a peer node, for instance, he can only transact and basically read transactions. But how does it then work? If we look to the process about how a blockchain and a transaction works, it is first a transaction. Maybe I send to Tom 1 Bitcoin, and we create that transaction. Then I broadcast that transaction to the network. Now, the node, the peers are going to validate basically that transaction. And when it passes, let's say, the validation, a new block on the blockchain is being created. And basically, each block, it's a bundle of the transactions that are done in a given time. And they are packed together and added to the blockchain as an extra block. All these blocks are connected together, and they are all chronologically connected to each other. And when a new block is created, that gets distributed to all the nodes, and then a transaction is completed. So the way about how to secure, let's say, these transactions is done in this process. Then on top of that, to make it even a little bit more bigger, we have a lot of types of blockchains. It's a different way. For instance, Bitcoin, the most known blockchain, it is a public blockchain, and it is, let's say, everybody can, let's say, execute transactions, can read the transactions, and can validate the transactions. While, for instance, when you look, for instance, in consortiums, in a supply chain or corporates, they most of the time want to have more control, and not everybody should be able to access those transactions. And then you can have, for instance, a private blockchain, so only people that are given access can basically participate in the network. Yeah, all those blocks, as I said before, they are all chronologically together. What is also very important is that they are basically secured together, is that there is only, let's say, one way about how the blocks can be as a puzzle together. And they use cryptographic functions, so mathematical equations to create this security. and also to make able that nobody can tamper with it and nobody can just hack. To give you an idea, the current word, for instance, of Bitcoin is quite a lot. And so there is, let's say, a big bounty if somebody can hack it. And from day one, a lot of people are trying to hack it. And up until now, nobody was able to hack it. And yes, but then you say, I heard about hacks of Mt. Gox or a certain exchange. Now, these are centralized parties that basically, they got hacked and they used the blockchain and they didn't take care of the security. And so the blockchain did not get hacked. But of course, we need to be careful when we use it, is that third-party services, so a middleman can be hacked. But the blockchain up until now, for instance, Bitcoin, has never been hacked. So what does blockchain? If we take the example of Bitcoin, it kills basically the middleman. Normally, we need a bank, a third party, to basically make sure, a centralized, trusted party, to make sure that the ledger is kept in a good way and that the records in there are validated. This creates delays. I don't know, sometimes when, especially when you say send international, for instance, money, it can take some days before your money ends up in the other person's account. While with blockchain, we take out this middleman and we do direct peer-to-peer, so it's almost instant. And this, let's say, takes away these delays. On the other hand, it is immutable. So because it's safe stored on the ledger throughout the whole world, there are different copies, nobody can just, let's say, edit or remove a transaction. And this immutability is also a very important one, because this generates a lower audit cost, because you can basically generate processes that are compliant by design. And on the other hand, it creates that for compliance reasons, you don't have to prove afterwards that you are compliant. No, you can show in real time that you are compliant. And other thing, and I'm going to mention it briefly, it's zero knowledge proof. Why do I mention it? It's a way about a transaction that can be done. It is that not all information you want to basically to be open and transparent and everybody can see it. And blockchain has generated a way of transacting with zero knowledge proof, is that it can check certain information without giving the information. So to give the example, here in the Netherlands where I live, we can only buy alcohol from 18 years or older. Now I have to show my identity card, which my identity card shows a lot of more information. It shows my birthday, it shows my social security number, and much more. And actually, when I need to prove, I don't want to give actually all that information away. So what zero knowledge proof does is basically, in a transaction, the question is like, okay, is Yannick 18 years or older? It will check without telling my date of birth, but it will only say, yes, 18 years or older. So in this way, we can give proof without giving the actual information. A smart contract. A nice thing about blockchain is that we can make use of smart contracts. And smart contract, the name is a little bit confusing because it's actually not a contract as we know a contract. It is actually a smart transaction. Well, the nice thing is that we can add code, we can add constraints, we can add triggers to a transaction with a smart contract, and that automatically is being done. So for instance, when you deliver something, it triggers automatically at delivery that the payment is done, to give an example. Then, so it's smart, it's automated, and it's end-to-end. It is between the parties in between. It's basically a script that executes data, and it changes the state of the blockchain. And why is this so interesting? It is because you increase basically the speed of execution of a transaction. You reduce the risk because it is already, let's say, agreed upon before, and it is automatically being done. Later on, we will see some examples which will make it much more easy also to understand and to make it tangible. Then we have the wallet. The wallet is basically like the bank account. It's like where you hold, for instance, your Bitcoins, and you have different types of wallets. It could be like a paper wallet. It's just A4 printed with the information to get access to your bank account, basically your vault on the blockchain. But it could also be an online service, or it could be like a hardware wallet, which is the most safe. It's very with, for instance, Bitcoin, because almost you are your own bank, but it also comes with a lot of responsibility. Because the wallet has two things, basically. It's that simple. It has a public address. It's like your bank account number, your IBAN, your SEPA, and this you can give to other people so they can send you something or transact with you. Then on top of that, you have the private key. This one is only for the owner because it is basically the key to your big vault. And this one you need to keep safe because normally with your bank account, for instance, when you lose your password or your access, you can call somebody and they will reset your password and you have access again. That doesn't work with the blockchain. If you are the owner and controller, you have that responsibility also to keep that safe. And now we come upon, why is it being kept safe? It is done by cryptographic functions. It's a very complex topic. I try to just touch upon it so you have a little bit of an understanding. And it works like this. We have a text document or a word, let's say blockchain, the word blockchain. It's plain text. We use an encryption function. And what it basically does, it creates from that word, it will create an encrypted text. And it can basically, we cannot as humans interpret it. And basically we also don't know what to do with it. But when we have the decryption key, and we put that encryption text in it, it becomes the word blockchain again. And this is basically what's being used to keep the blockchain secure. And also on the right, you can see, if we hash blockchain as one word, it has an output. And when we use block space chain, it has a completely different output. And this way, it's being used to encrypt the data and to make sure that only the people with the private key can decrypt the information that is theirs or get access to their wallet or to sign a transaction. Because basically when we're setting up a transaction or we're creating something on the blockchain, when we do a transaction, we're creating a digital signature. So to give you the example of, for instance, a certificate, it's basically that the data on a certificate get hashed. Now that's nonsense that we cannot interpret it. Is being encrypted with the signer private key. So only the signer has that key. And it creates the signature of basically the digital sign. So you have the certificate plus the signature, and that's basically a digitally signed data, as we can see on the left side. If we go and verify, then we need to have the data plus the signature, and if we put it through the hash function and both are the same, we know it's the verified data. If that is not the case, we can say this data is not verified, this data is not correct and has been tampered with. We cannot accept this. This is basically, in a nutshell, about digital signatures. There, I clicked the wrong button. I'm sorry. Let me get the presentation back. And there it is back again. So these were a lot of buzzwords, and there's much more to tell about blockchain. It's a very complex technology, and I want to congratulate you. You're now master of blockchain, and you still have no idea what we're doing. And I am already since 2012 involved with blockchain, and I'm still learning today. In the end, it's not about the technology itself. It's about application. We all use email, we all use internet, but we also don't know how the HTTP protocol or the SMTP protocol really works. In the end, what we know is how we use it. So let's deep dive into possible ways about how to use it. So we talked about the wallet, we talked about the bank account, and normally we link that to money, to the exchange of value in terms of euros or US dollars. But with this bank account, you can do much more. I can send somebody a message and it can be kept. I can give a vote. I can give a rating. I can, let's say, validate certain information, and it can digitally sign documents like we normally do with a notary. So we do much more with a bank account on the blockchain than just money like we used. Of course, the way how we vote, how we engage with governments, how we can create, let's say, governance structures, it can be completely different. For instance, also to vote now in the times of Corona, it's not possible because we cannot go to a location with all people together and to make a vote. Via the blockchain, it could be possible in the future to do this from your own home. For instance, in Estonia, they do this already. But also we can use it to basically track certain data. So through all the supply chain, we can track the carbon footprint of a product. And in this way, well, because we can track this, we can also look for responsibility and how to deal with it. Who is responsible? Who adds the most, let's say, emissions and needs to take care of that? Because it comes all open and transparent. It's a possibility. On the other hand, it's the way how we consume energy. For instance, in Brooklyn, the Brooklyn project, it's a blockchain product where people with sustainable energy, so they have their own solar panel or their own wind turbine, they are connected to a peer-to-peer network. And basically what they do is they transact the energy from each other. So when I'm not home and my neighbor is using some more energy, I will sell my energy to my neighbor and the other way around. Currently, we have a centralized way, a very well designed way to have access to energy, but it's not optimal. To always have that access, a lot of energy get lost. And we also have like a 1 or a 2 price model. While if we have this peer-to-peer way of transacting energy, you get a flexible price all the time. And in this way, combined with, for instance, smart technology like AI, we can also optimize with storage and so on, much better energy consumption. Then if we look, for instance, to accounting, now companies have to keep their own, let's say, accounting, their own ledger about everything they do, and they have like cycles where auditors will check if they, let's say, were compliant. Well, with blockchain, it could basically be the other way around. You're in real time, you are basically compliant. You're in real time, basically have your process that is compliant by design. And then if we look to the supply chain, within the supply chain, it's of course a very complex, let's say, process. And it's very interesting and very amazing how humankind created such complex systems and to create, let's say, on the global scale, certain products. But it's also not optimal. And a lot of times there are silos of data, let's say, within companies that are not shared through the supply chain. So this creates a not optimum, let's say, process. While we create the trust with blockchain, we could maybe make this more and more reliable and more workable to share more data, to use that, for instance, to protect yourself from fraud, or also to be much more assured about the quality of your products, about the data that is presented to you by supplier or by a client, and that is validated, and you know that is the real data and cannot be tampered with. So this is, I hope I gave enough grasp for all of you to have an introduction. Of course, in a short time, I cannot explain everything. Luckily, there is a lot of information present online. Just Google in what you're interested, or send Tom or me an email, and we try to help you. And now I want to give the floor to Tom, and he will give you a real tangible example about blockchain in oil and gas. So Tom, the floor is yours.
Yes, thank you, Yannick, for that great talk. And now I want to become a little bit concrete. I want to show you here a possible supply chain of steel. And this could be a supply chain of a pipe that moves from a plate mill all the way up to an oil and gas company. And as you can see, there are many parties involved. There are parties that are adding to the product, like Outokumpu, creating the plate, Inox the pipe, Van Leeuwen, they buy a large amount of pipes, and so that they can sell them in smaller quantities to the EPC. And then there are tests being done on those products, and there are people that want to witness those tests, so to make sure that, that the tests are executed correctly. And all these people have to sign off on certain parts of the supply chain. And right now, that is all being done on paper. And that means that every time the product moves from one party to the next party, everybody has to check the paperwork manually again. While if you would digitalize this, that could be done automatically. So SteelTrace, what is SteelTrace? We're a platform where all the parties in the supply chain can work together and exchange data. And customers can set rule sets for their specifications, and all the companies that are involved, laboratories and notified bodies, can supply their data to this platform, and it will instantly be checked against the customer specification. And because of the digital signatures and the cryptographic keys we use to identify people, we know exactly who put in what piece of data at what point in time. So we already talked about the blockchain, and today we're going to look into a use case that involves a web application. The web application is used to access the platform, and then there's a mobile application. And you already had heard before the word wallet, and the wallet is the key with which you can identify yourself. We store that in an app on the mobile phone, so that everybody that needs to take responsibility for a part of the data, whenever they have to do this, they can identify themselves via the mobile phone. Nobody has that private key, not even us, so we can never falsify a transaction. And now I will switch my screen to the actual platform. and show you how this works in real life. So what you see here is the interface for a producer of a pipe. And in this case, we're going to create a certificate for a plate. So this is a plate mill. And we can add an address, we can put in a heat, we can put in the norm, 240, give it a certificate type. And this is a duplex pipe or plate right now, and it will turn into a pipe later. An internal ID that can be linked to your ERP system. And some information about the marking of the pipe. It's just, you know, it can be anything. And now what I'm going to do is I'm going to create this certificate. First I have to, of course, give in the information about the product. Let's say it's 100 kilos. There's a width of 6,000 or 3,000, height of 6,000. And we create it. And what happens now, I need to take my phone to create this, this element. And I will show you how that works. This is what you see on my phone now. And we scan the QR code, we put in a 5-digit ID with which to identify yourself to unlock the key. And now the signing is a success. And we can go back to the application. And indeed, the signing was a success and the new certificate has been created. So this entity now exists on the blockchain. Now, the next step is that I want to start adding tests. And in this case, example, I'm going to keep it simple. We're just going to do the chemical composition. And we're going to use a laboratory to execute this test. And we want a witness to be part of this test. I'm going to create it. So now I'm going to tell the blockchain, hey, I'm going to ask this laboratory to execute a test on our product. Again, I sign it. And don't worry, all these actions don't have to be signed one by one. We can batch transactions. And as you can see now, we are waiting for the results from the laboratory. So now I'm going to the laboratory account. This can be a completely different company somewhere on the other side of the country where you sent your sample. And as we can see, chemical composition has been requested by the plate mill today. And there's a list. And we can add it. Now, I have to give some information about the specimen, test standard, norm, and the grade. Remember, we put in 31803. I'll just give it a test. And in this case, we're checking the base material. And as you can see from the database, the min and max values of the chemical composition automatically come from the norm database. Now, as you can see here, the nickel value has these min and max value, but this is a pipe and it's used for Total, and Total has an exception. They have a different value they would like to use for the nickel. So these exceptions can be programmed in. And if we add them, you can see that the exception has been added, and now the min-max value of the nickel has been changed. Now, I'm going to enter this information in a simple way so that we make sure we're compliant in this case. And there it is, we are acceptable. The print is above 34. Now, it could be that you want to have some other elements in it. and use the elements in the pren, diverting from the norm. You can set your formula, use any element that is available to create your own pren formula, and the formula will of course be shown on the certificate. I'm going to save it now, and of course, as a laboratory, I now have to sign it and take responsibility for the data. Now, earlier you heard Yannick talk about hashing and the ability to encrypt information. Now, what's going to happen when we sign this, the laboratory person will take out their phone and sign this information, and we will add it to the blockchain, but not the actual data, but a hash of the data. So only the owners of the data can see the actual data, if you have the actual data, you can verify in the public blockchain that that data has never been changed. Now I go back to the plate mill account. To the certificate, and as we can see now, the information from the laboratory has been shown, has been transferred. And we see that something has been made bold as an exception. We can see what the default boundaries were. But I gotta go back to the laboratory because we forgot one thing, and that is this had to be witnessed by somebody. And how that is done, traditionally, somebody does the test on Monday morning. On Tuesday, they have time to make the report. Then they send it to the notified body that was there during the test. He takes a week to look at it, sign it, and then 2 weeks later, boom, you have your information. In our system and our way of work, this is done instantly at the test site. So just the laboratory person has signed, and then he can click approve. And now the notified body is scanning this and approving. There you go. Now I'm going to go back to the manufacturer's account, open the certificate, and there you go. An independent notified body has attested this test. And we see all the steps. There was a lab assigned, there was a witness assigned, there was a laboratory that put in the data, and then there was an independent notified body that checked it. And the only thing that is left is for the quality manager to also sign off this document. And that's me, so I'm doing that. Now, while we're waiting yeah, there it is. Now we are ready to send this on to the next customer. Of course, in real life, there's a multitude of tests attached to this certificate. For the example, we limit it to the chemical composition. And now we're going to transfer it to a customer. And we want to create a pipe out of it. And pipe mill 1 is going to do this for us. And pipe mill 1 has supplied us with some information that their ERP system is working with. And we want to give them that information so that they know the certificate has arrived and is according to spec, and that the invoice can be paid. And again, this is also something that we have to sign, because we're now telling the blockchain that the ownership of this certificate has transferred from company A to company B. Now, I apologize for the slow internet when I'm streaming, and it takes a bit longer. Now you see that the certificate has disappeared here. Now we have an archived version. The archived version is a non-blockchain version. Transferred. It is just for the purposes of your own archiving that you can see into your paths. And now I'm going to log out, and I'm going to go with the pipe mill. That has just received a certificate. And they received a plate, as you can see, with the right dimensions, the norm, the grade, etc. And now we're going to go into the next step, because this plate has to become a pipe. Now, this is the certificate. If you have a certificate that is transferred, you always have the information above, so you know to which order it belongs and for which project it was. You can see the full trace of the ownership. So this used to be from the plate mill. And now what about the next step? Because we have a norm here that refers to a plate norm, and we have information here that refers to a plate. We have to convert this product type into a pipe. And this becomes A9 class 1. Okay, so now the product information changed, but the tests are still there, and now the piping company can start to add their data. So we can add a test, and let's see, let's do a hardness test, or maybe an impact test. Okay. I'm going to ask for this example purposes to, again, the same laboratory, but of course it can be any laboratory in the world that you want to work with. Create a test. And now I'm just shortly switching my account on my phone to the plate mill account. There we are. So the process is the same for the next company in the supply chain. They can do exactly the same tasks. And now we're waiting again for the results. Now let's fill out this impact test. As you can see, an impact test was requested by the pipe mill. And we're going to add some information here. It's a V-notch. 10 by 10. And we have exactly this grade. It was as if we knew this was coming. And we also have an exception for Total, which means that they only need 34, but we can keep it in the standard for now. Add a little norm. Some information about the lab. Now, this can be done, of course, because we have a welded pipe. We can do all the zones, but for this example, I will just, for the time, use the base material. It has to be above 54, but what if it's not? It's not acceptable. And what if we move above? It's acceptable. Why? This is not acceptable because according to the norm, one of the values can be below the max of the minimum value as long as the average is still above. And therefore, this is still a valid product. We can press save and we can press sign. And now the laboratory will sign this document again. Again, this can take a little bit of time because we're streaming to 50 people all over the world. There it is. Now we don't have a test area popping up here because the producer did not request a witness to be present at this test, and therefore they're not present. Now let's go back to the producing company. And as you can see, the impact test has been submitted and is waiting for approval. The lab has been assigned by the pipe mill. The laboratory has submitted the data and has signed off on the data. We still marked it as red, just so the quality manager knows what to look for when he's going through the certificate. But all in all, it is satisfactory. And now, of course, I can sign this again as the quality manager because I think it's acceptable. And then we have a pipe certificate ready to send on to the customer. And I'm going to, let me see, transfer this product. I'm going to use, in this case, you know, we could send it to Total or Cytec, some of the end customers we'll work with, but I'm just going to send it now to SteelTrace producer and pretend that is the end customer. And I'm going to send it on. You see, as you see, quality management becomes as easy as pie, because what you've just seen is days and days of waiting for information to move around, emails to move around, orders to be put in place, PDF certificates to come in, to be typed over on the new system, etc. Let's go back here. Yeah, as you can see, the pipe that we ordered arrived and all the information is present. And I can see that it used to belong to the plate mill, then it went to the pipe mill. You can see the full data trace. We can see the information the pipe mill added. We can see the information that was added by the plate mill. And altogether, we are happy with what we're seeing here. And this is another interesting part. These numbers have changed, because now we put order numbers hard stamped or hard typed on certificates. That means that if they move along the supply chain, the old order numbers are still present. This is unnecessary. The only thing you want to know as a receiver of the certificate for which order number you gave out that it belongs to. And it's only relevant to you, your project. You don't care about the stuff that happened before. We can also see from which plate this pipe was made. And, you know, of course, in theory, we could now change this into a band or change this into a fitting. So yeah, this was the presentation of our product. I hope you guys all liked it. I see we still have a lot of attendees left. If you guys want to know more, we have some other features coming up that we didn't show in this part because we have to constrain the time. But yeah, feel free to contact us, Tom at SteelTrace.eu or Yannick at SteelTrace.eu if you have any questions, and if you would like to start with us today.
Yeah, I want to thank you all, and we stay in touch. We will also send you afterwards an email with a link where you can review basically the recording of this webinar and maybe share. And also feel free to reply on that and to ask for any questions that are still left, or maybe you want somebody else to get more information about it. Just share them our information. I hope you enjoyed it. Thank you very much, and hopefully we see you soon. Stay safe, stay healthy. Bye-bye.
Bye-bye, guys.